In this lesson, we're going to be looking at equivalent areas, which is changing plane geometrical shapes to other geometrical shapes while maintaining the same area. So we're going to shape one shape to another while the area remains the same. How do you find the area of the irregular plot of land as shown in the question there? Well, one way is to convert the irregular shape to a regular shape with the same area. Now let's look at triangles. Triangles standing on the same base and have the same height will have the same area. So if we have triangles between parallel lines representing the height and they are on the same base, then they will have the same area. The area is base by height over 2. If the base is the same, the height is the same, then the area would be the same. Now let's look at the relationship between triangles and rectangles. So if you have a rectangle with base and height, and you draw a triangle within that rectangle with the same base and height, then the area of the rectangle is base by height, the area of the triangle is base by height over 2. So hence, a rectangle with the same base and height of a triangle has twice the area of that triangle. For a rectangle to have the same area as a triangle, the rectangle must have half the height of the triangle. So if the rectangle is half the height of the triangle, then the rectangle is equal in area to the triangle. Now let's look at the relationship between squares and rectangles. If we have a rectangle with base and height, and we extend the base by drawing an arc equal to the height of the rectangle, and we erect a semicircle on the new base, a square could be drawn by extending the rectangle at the point that we drew the arc to touch the semicircle. That line represents one side of the square, and once you have one side of the square, then we could draw the square. That square is equal in area to the rectangle. In the picture below, we have a survey map showing some plots of land. They are irregular in shape. We have some quadrilateral shape. We have a pentagon shape. And how can we find the area of these irregular shapes? One way would be to convert them to simpler shapes. For example, a square, a rectangle, a triangle, which are equal in area, but they are easier to find the area of. Equal in area to an irregular quadrilateral. So if we have our irregular quadrilateral and we connect the diagonal and we draw a parallel line to our first diagonal from the other corner, and we extend the base. That space in between there, if we connect the line there, will give us a triangle equal in area to our irregular quadrilateral. Triangle equal in area to a pentagon. So in this case here, we have a regular pentagon. And if we connect the diagonals and we extend the base and we do parallel lines to our diagonal, what we would find is that the space in between is a triangle equal in area to that regular pentagon. Now we're going to be putting what we have learned so far in one drawing. A square equal in area to a pentagon. In this case, we have an irregular pentagon and we want to get a square. We can't go directly to a square. What we must first do is go to a triangle, and then from that triangle, we can go to a rectangle, and from that rectangle, we can go to our square. So now we have a square equal in area to our irregular pentagon, and it's easier to find the area of the square than the area of the pentagon. Thanks for watching.